Hello everyone, let me briefly introduce myself. My name is Aisan Rafie. I finished my master's thesis in biomechanical engineering at the Iran University of Science and Technology recently, and I'm delighted to be here today to present our article entitled Biomechanical Study of Fused Lumbar Spine Comparing Titanium and PEEK as Connecting Rod Considering Bone Degeneracy Using Finite Element Analysis. To write this paper, several steps have been taken successively, which will be discussed in detail in the next slides. First, we trace the indicators that form the purpose of this study. Lumbar spine fusion surgery is a standard procedure for treating lumbar spine disorders. Using a stabilizing implant system with a pedicle screw and connecting rod is one of the most widely used methods, but the challenge of fixing the pedicle screw in osteoporotic bone has always been one of the obstacles in this type of surgery. Over the years, there have been investigations into strategies to provide solutions to this problem. And all these issues together constitute the purpose of this study. The purpose of fusion surgery in the lumbar spine area is to treat problems such as lumbar disc, spinal tumor, spinal fracture, scoliosis, spinal canal stenosis, and similar problems. The reasons that make this issue very important are as follows. The importance of the spine in maintaining body strength, protecting the spinal cord, and human movement. The prevalence of fusion surgery in the lumbar spine area. The increasing prevalence of osteoporosis. The silence of osteoporosis until the first fracture. Vertebrae is the most common fracture site due to osteoporosis. Lack of studies on practical issues such as geometry and materials of implants used in fusion surgery. The need to improve the quality of fusion surgeries. There are previous studies in this field, some of which I will present to you as selected ones. Jost et al. And Werner et al. In their research in 1998 and 2019 concluded that fusion surgery in osteoporotic bones is much more complicated than in healthy bones. Low et al. In 2003 announced that osteoporosis leads to higher stress concentration in the annulus fibrosus, articular facet, and lamina. Liu et al. In 2017 stated the underlying cancellous bone density is a more critical factor for the biomechanical behavior of the implant stabilized motion segment and its final clinical success. Biswas et al. In 2018 and Akinci et al. In 2022 compared the types of titanium alloys, polyether ether ketone, and polyethylene for connecting rods and investigated their effectiveness. Oikonomidis et al. In 2020 investigated two types of fixation systems, titanium screws and rods and PEEK screws and rods, on the corpse of a person with osteoporosis. Nico et al. In 2021 investigated the effect of connecting rod material in the parametric model of fusion surgery. And the purpose of this study is to investigate the effect of the selected material for the connecting rod in fusion surgery, considering the reduction of bone quality. Modeling for this project has been done in several main parts. 1. Creating a 3D model of the lumbar spine in Mimics. 2. Improvement of the finite element model in Trimatic. 3. Redesigning the implant in CATIA. 4. Model solidification and assembly in CATIA. 5. Model meshing in HyperMesh. And then the model was transferred to the HyperMesh software. After analyzing the sensitivity of the mesh due to the sharpness of the threads of the pedicle screws, the value of 0.75 was chosen for the sides of the element so that we do not have any confusion in shape. The number of elements of the fully assembled model is in this table. The tetrahedral element is used and the pedicle screws and vertebrae contact volume is evacuated from inside the vertebrae. The model was transferred to Abacus software as an orphan mesh. The material allocation was done and 4 types of quality for the cortical part and 4 types of quality for the cancellous part were used to represent osteoporosis in the model. Then, the interaction between the parts was applied according to this figure. Finally, 4 types of movement: flexion, extension, lateral bending, and twisting. 4 types of bone quality: weak, normal, strong, and very strong. And 3 body weights were considered for model analysis compared to 2 cases with a titanium rod and a PIC rod. According to the initial validation to ensure the model's accuracy, the results indicated that in both fused and intact states, the stress concentration in the intervertebral discs with an average error of 13% is consistent with the study of Jain and Rajik Khan. As seen in the diagrams for the model with PIC connecting rod, the stress concentration in the whole model has decreased significantly with a decrease in bone quality. The diagrams of flexion and extension can be seen in the slide, and the other 2 modes are available in the main text of the paper. Also, this reduction can be seen for the screw and bone contact surfaces. When bone quality decreases, both types of titanium and PIC materials for the rod show a significant stress reduction. The internal pressure in the intervertebral discs in the model based on the PIC connecting rod is slightly higher than in the model based on the titanium connecting rod. Furthermore, the load displacement relationship of fused cases under varying load conditions during flexion, extension, lateral bending, and twisting is also rendered. This graph shows load displacement behavior concerning the effect of composing loading under various body movement conditions in the whole model. For flexion, extension, lateral bending, and twisting, the displacement of the entire model varies from 0.77 to 1.635, 0.768 to 1.634, 0.768 to 1.633, and 0.768 to 1.633 mm respectively. With the process of reducing bone density in both the dense and spongy parts of the whole model, the PIC-based model for the connecting rod has a lower stress distribution at the contact surface of the screw with the bone, reducing the bone quality. PIC material is more suitable for the connecting rod, but in good quality bones, titanium is preferred. The stress concentration on the intervertebral discs in the case of normal bone and the displacement of the entire model is higher in the PIC rod-based implant system than in the titanium rod-based implant system. The amount of this difference is such that it can be ignored if the PIC rod can create less stress in the poor quality bone and prevent the screw from breaking or loosening. Therefore, choosing a PIC connecting rod for weak or osteoporotic bones is justified. Secondary validation was also done with Akinji et al.'s model, which is in good agreement due to the difference in segments and incoming forces. As a general conclusion, I can offer you the following. 1. The maximum stress on the titanium connecting rod and PIC is 110.8 and 9.366 megapascal respectively. Titanium and PIC yield strength is 800 and 102 megapascal respectively. So we have a safe distance between the obtained stresses and the yield strengths in the connecting rod even at higher weights and similar movements. 2. Also, the results obtained from this study, in addition to paying attention to the surgeon's diagnosis regarding the possibility of increasing osteoporosis in patients undergoing lumbar spine fusion surgery, can provide surgeons with the possibility of replacing the stabilizing implant system based on the PIC rod with the stabilizing implant system based on the titanium rod. And these are some of the prominent references for this study that have been used in this direction. Well, that's it from me. It was a pleasure being here today. Thanks a lot for your attention. I'll gladly answer any of your questions.